we've had a very beautiful lecture and tutor shape on exponents and bases. The first two videos we discussed those axioms and those rules that have to do with bases and their powers, exponents and all that. And there was a lot of exposition on that. And the next video now we want to go further and we can apply all these rules and axioms to solve a lot of problems in mathematics. Now the first rule I want to introduce is this rule that says that should be the seventh rule. That should be the seventh rule. The rule simply says if we have b raised to the power of m equals to b raised to the power of n. The truth is that m, then n will be equals to n. This is simply saying if I have two bases equal on the other sides of an equality sign. So you have an equality sign and you have this one here, I have this one here. And the most important thing is that the bases are equal. The rule is saying once the bases are equal, the powers are equal. So even if the powers are different, like m and n are like different variables, the rule is saying that they are actually equal. So how does that work? It's really interesting. So somebody will ask, can you prove that? Yes, it can be proven. So let me decide to divide both sides by b raised to the power of n. I'm going to have b raised to the power of n divided by b raised to the power of n, and this will be b raised to the power of n divided by b raised to the power of n. You see, this is quite interesting. This actually, you have them equal. Since you have them equal, that is going to be 1. It's obvious that this is going to be 1. And on this other side, we have, this is going to, by the second law, you remember the second axiom, this is going to be b raised to the power n minus n. And remember we said that, if you have 1, this can be written as b raised to the power of 0. B raised to the power of 0. So if that is true, it is obvious that n minus n is actually equals to 0. That is what it means, because if this is b raised to the power of 0, then this is equals to 1. We have said that already. We have proven that in the third rule, that any number raised to the power of 0 is 1. So if this is raised to the power, let's just put our hand here, and b is equals to 1. No, what is supposed to be here is supposed to be 0. So what it means is that this n minus n is actually 0, and you can see that if we add n to both sides, or the local way, some people say move this down there, but that is not actually correct mathematically. The correct thing is that we add n to both sides, n will be equals to n. So you can see that this actually agrees with this. So that is actually a clear proof to that. But let's solve problems on this. Suppose we have something like 25 raised to the power of x plus 1 equals to 625 raised to the power of x minus 1. Scary looking thing. But all I want you to note is the equality sign, bases and powers. That's all I just want you to note. Forget about the numbers and all the scary looking x and that. You have an equality sign, you have this. But this doesn't look like this, because 25 and 65 are not the same. 25 and 65 are not the same. But what can I do? It is obvious that 25 can be written as 5 raised to the power of 2. So you can check that in your multiplication table. So this can be written as 5 raised to the power of 2. Don't forget that your x plus 1 is still here. And 625 is the same thing as 5 raised to the power of 4. How do I know that? Think about that. This 5 raised to the power of 4. This is 25. This is 125, and 125 times 5 will give you 625. That is how we got that. Now, you remember the other rule I talked about in the former video? We can always multiply these powers. That's what this rule says. We can multiply this power. That's what the rule says. So this can be given as 2. Please always use a bracket whenever you're multiplying things of this nature, scary looking things of this nature. So just use your brackets to multiply them. Now, look at this rule. It simply says once this and this are the same, equate the powers. Once the bases are the same, equate the powers. So you can learn that like an acronym or like a poem. bases same equate powers. Bases same equate powers. The bases are the same, equate the powers. So the bases here are the same, I equate the powers. So I equate the powers or the exponents, and that is going to give me powers are actually 2 into x plus 1 equals to 4 into x minus 1. So I can actually forget about the basis for now, just equate the powers, and these are the powers. And let's go back to basics, elementary mathematics. I'll open this bracket. 2 times x is 2x, 2 times 1 is 2, 4 times x is 4x, 4 times minus 1 is minus 4. That is called expansion. It's called distributivity, opening of brackets. So this is, we'll collect like terms here. Collect like terms. Collecting like terms is going to be 2x minus 4x. I'm subtracting 4x from both sides so that I can have this here. I subtract 2 from both sides so I can have it here. Minus 4, which is already here, and minus 2, and that will give me minus 2x minus 6. So please, that is a review on your number line. It's minus 4 minus 2 is minus 6. Just having 2 negative numbers, and I'll give you more negative numbers. Minus 6, 2x minus 4x, you have minus 2x. So I can divide both sides by minus 2 and have my x, and this will cancel it, and I have my x to be equals to minus 6 divided by minus 2. 2 negative numbers dividing becomes positive, so this will be equals to 3. So actually the value we have there is x equals to 3. So these are called exponential equations. Take note, I didn't want to start the topic by giving the big terms. So these are actually called exponential equations. Exponential equations. Some texts will call it initial equations, so on and so forth. So that is how we deal with that. So, but the simple thing is that if I have 2x to the power of maybe 16, and that will give me 2x to the power of 16. Remember, it's 2 raised to the power of 4. 2 times 2 times 2, 4 times. And you see the bases are the same. So hence, we have a smile on our faces. Wide smile. Faces that this is x is equals to 4. So this is simply how we can apply this to solve basic initial equations. And those equations are equations you see over and over again. So I'm going to test you by giving you your own assignment. Don't be sad about that. Just want you to be anxious. So this is what you're going to do with my little box. We're going to try 27 raised to the power of 2x minus 1 equals 281 to the power of x. So I want you to give this a try and find, obtain the value of x, obtain the value of x. So you can always discuss with me on my email, sammykmf@gmail.com. Remember to share the videos. Remember to also post it to any student in college or high school who may be having problems or challenges in basic mathematics. In the next series, I'll be going to something totally different, but it's actually a sequel to this, and that will be the Napierian logarithm, or what we call the common logarithm, or the hyperbolic logarithm. Thank you very much. Bye.